for the force of attraction. Sometimes we'll put in, for two forces that are charges that are attracted, we'll put in a negative Q and a positive Q, so we'll show that the negative form of that means they're attractive, and the positive forms means that they're repulsive. So that's all that is. It's essentially the same thing, and it's really conditional based upon what you're defining as your positive y direction. But typically when we're working with numbers, not symbols, but numbers, I always like to just say that acceleration y is negative 9.8 meters per second squared, and we just stick with that when we're working with the numbers. But if you're dealing with symbols, sometimes this is more useful. Okay, sometimes this is more useful. So it really depends on what you're trying to accomplish in the problem. Really deal with, we just because it will just change the sign of our final answer in this case. And I want to solve for delta y. That's going to be my max height. And when I distribute this squared property through to the sine and the v initial, and then I subtract that over, I'm going to get negative VO squared sine theta squared, and then I just divide it by 2AY. And I'm going to get this equation here. Now, you may see this written a little bit differently sometimes. They may write it like this. You may see this in textbooks written as this. And so you may see it written as H equals VO squared sine theta squared over 2G. And that's just recognizing that acceleration of the y is negative g. G is just a number. It's a constant, which is assuming that if you're close to the Earth's surface, that the acceleration or the field, the gravitational field, is the strength of that. The magnitude is 9.8 meters per second squared. But it really depends on the direction in which you define your axis. I mean, if you define your axis as down, g will be positive. If you define it up, it will be negative. So when we get into forces, we're going to see that it completely depends upon the direction that you define your positive y-axis. You can define your positive y as down, and g will be positive. You can define it up, and g will be negative. So in this case, typically we would just say that the y component direction is up, and so acceleration of the y is negative g. When you do that, the negative sign drops out here, and so this just becomes positive. So they're exactly the same thing. It's just you're substituting in a symbol, and you will see a similar thing when we get to charges. Coulomb's law for the force of attraction. Sometimes we'll put in, for two forces that are charges that are attracted, we'll put in a negative Q and a positive Q, so we'll show that the negative form of that means they're attractive, and the positive forms means that they're repulsive. And that's all that is. It's essentially the same thing, and it's really conditional based upon what you're defining as your positive y direction. But typically when we're working with numbers, not symbols, but numbers, I always like to just say that acceleration y is negative 9.8 meters per second squared, and we just stick with that when we're working with the numbers. But if you're dealing with symbols, sometimes this is more useful. Okay, sometimes this is more useful. So it really depends on what you're trying to accomplish.